Hello and welcome everybody. So today we will learn that how can we do the statistical analysis and interpretation of data using JMP software. Already in the previous video we have explained the basics of the statistics and how can we do the normality test, the basic concepts and the probability distribution functions. So here we will learn only that if we get a data or whatever data we get from our experiments or our research, how to apply the statistical analysis and inference in the JMP software. That is the main purpose of our video. So this is a data, already it's tested to be a normal data or a normal distribution data. So what we will do is, first we will copy this data. So this is the sample name and this is the parameter, let's say. So what we will do, we will copy this particular data, then Control C. We'll open JMP. This will be the screen of JMP software. We will go to new. We will go to this one. That is the new data table. We will click on it. Okay. We'll maximize the screen. Simple. What we'll do? We will Control V. That is, we'll paste the data. Okay. Now remember that always when we are analyzing any kind of statistical like data or statistical interpretation, this is the factor. Okay. And this is the variable part. That is, this will never change, but this may change depending on a particular experiments or factors. So first, in order to understand whether the data is really a normal distribution data or a non-normal distribution data, that is, whether the data set that we are handling follows the normal distribution or a non-normal distribution, we have to go for the normality test. For that, what we will do, we will select these two columns, we will go to analyze. We will go to this particular first option, that is the distribution. Okay. Now we will select only column 2, Y columns. Okay. So we will get this particular screen. So then we will go to this drop down arrow of column 2, normal quantile plot. See, apparently we are getting that, apparently or visually we are getting that it's a normal distribution, because this is the confidence limit and this is the identity line or the standard normal line. Okay. But the data might be non-normal. We don't know exactly. So what we will do? We will go to again continuous fit normal. So this is a histogram fit. So you can see from here that this particular has a skewness and it's left skewed. Why? Because it's a left tail. Now in order to properly confirm whether the data set is normal distributed or non-normal distributed, what we will do? We will again go to this fitted normal distribution, this particular option. We'll click on the drop down arrow and we'll go for the goodness of fit. See, in the Shapiro-Wilk test is a test for normality. I have already explained this particular thing in the previous video. So if the value of this W comes out to be greater than 0.05, then yes, the data set is following a normal distribution. But if the particular W value is coming less than 0.05, then it will follow a non-normal distribution. So we have to remember this, that if our data set follows a normal distribution, then we will have to follow the ANOVA followed by the rookie test. We have already explained in the previous video. So what we will do is, we will minimize the screen. We will go to this particular table. We will go to again analyze. Now we will do the statistical analysis. Now we will go to fit Y by X. Okay. So now the most important part. As column 2 is a variable, not a factor, we will go to the Y response. Okay. And we will select this column 1 in the X factor. So in the previous video, what was done, as we are using the software SPSS, so here we have to write in numerically. But suppose if you follow the same method in JMP software, then what will happen is that 0, 0, 0, 1, 1, 1, if you do like this, then if you copy these two columns, then it will come to bivariate. So it's not a bivariate data, it's a one-way data, because one is a constant and another is a variable. Okay. So we'll click on OK. This one has come, right? So now in order to get the statistical analysis, what we'll do, we will click on the drop down arrow. We'll first go to means ANOVA. So the means ANOVA has already come. Again we will click on this drop down arrow. We'll go to compare means. Then we'll go to all pairs to be test. So ultimately we can see from here that it's A. So if the letter is same, it means that it's that the data is non-significant. That is, there is no significant change among the particular samples. Whatever experiment you do, but if there are letters that are different from each other, then there is a significant difference among the samples. Okay, so this is basically for a normal data. This is the first part of the video. Now I will show you how to get the non-normal data. That is, how we'll understand if a data is non-normal distributed, then how can we do the statistical analysis. So for that, what we will do, I'll just close the screen for your convenience. So this is our option. So we will go to the Excel file again. So this is our normal data. So already I have tested with non-normal. So we will simply copy, and then we will go to the again to the JMP. The same procedure. We will go to this option, new data table. Click on it. Simply we will paste it. Okay. So now the same procedure. First we will go to analyze. We will go to distribution. Okay. We will only click on the column 2, Y columns. Okay. This one will come. And now what we will do, we will column the normal quantile plot, right? The first point for visual representation, and again we will go to the continuous fit normal. So this might be non-normal, and this is very clear. Why? Because the graph is not centered. See, there is no central mode here. So automatically you can understand. But in order to confirm, what we will do, we will go to the fit this one, that is a fitted normal distribution. Goodness of fit, you see red. Red color indicates that it is a non-normal distribution. Why? Because it is less than 0.05. So if the data is less than 0.05, then automatically it's non-normal distributed, and moreover JMP will give you in red color. That's a big advantage of this software. Okay, so it's a non-normal distribution. So also for that we will use Wilcoxon or Kruskal-Wallis test followed by Dunn's test. We have already explained in the previous video that what is Wilcoxon or Kruskal-Wallis test and how things are done if the data set is non-normal distributed. So what we will do, we will minimize this part. We will again go to analyze. We will go to fit Y by X. Okay. Now the same procedure. The column 2 will be Y response. Column 1 will be X factor. Again the 1 way has come, so it's correct. Okay. Now what we will do, we will simply go to this drop down arrow. Okay. Now we will do non-parametric. Non-parametric means when your data is non-normal distributed, for that we will use the non-parametric testing. So already it's there in the previous video. You can watch it if you don't know anything about statistics for a basic like for the basic concepts. So we will go for the non-parametric part, Wilcoxon Kruskal-Wallis test. So already it has come. Now what we will do, we will again go to this particular down arrow, non-parametric. We will go to this non-parametric multiple comparison, and then we will go for done all pairs for joint, that is pairwise comparison for all the samples. You see the same thing as that is, this one is also a non-significant data. So from here we can understand that how can we differentiate a data set into a normal distribution and non-normal distribution using JMP. So if the data is normally distributed, we will use ANOVA followed by the Tukey test, and then if it's a non-normal distribution, we will use the Wilcoxon or Kruskal-Wallis test followed by Dunn's test. Thank you for watching this video. Thank you so much.